Our objective in this lesson is to determine the equation of a quadratic function when zeros are given. This is the third part of the series determining the equation of a quadratic function. In our previous lesson, we have learned how to determine the equation of a quadratic function from a graph. We have learned also that in a parabola, the points that crosses the x-axis are known as the roots. These are the values of x when y is equal to 0. That is why the roots are also called the zeros of a function. Let's have the first example. Find an equation of a quadratic function whose roots are 3 and 5. These are my roots, meaning these are my x values. So I have x is equal to 3 and x is equal to 5. I'll equate these two equations to 0. I'll move the constant on the other side. This will become x minus 3 equals 0. And this one is x minus 5 equals 0. Working backwards, this will be my factors. I'll multiply the two binomials. I have x times x is x squared. X times negative 5 is negative 5x. Negative 3 times x is negative 3x. Negative 3 times negative 5 is positive 15. Negative 5x minus 3x is negative 8x equals 0. If I want a function, I'll replace the 0 here with y. So I have y is equal to x squared minus 8x plus 15. Now, there is another way of solving this. Do you still remember our lesson on sum and product of the roots? I'm going to use them now. I'll determine first the sum of the roots. So I have 3 and 5. This will give me 8. While the product of the roots is 3 times 5, and this will give me 15. Recall the standard form of a quadratic equation. If I am going to divide all these terms by a and a here will cancel out. So I have x squared. And then I have b over a x. And then c over a. And 0 over a is still 0. Notice now that this b over a is the same as b over a here except the negative. This c over a is also the same c over a here. Let me rewrite this considering this negative here. This will be x squared minus negative b over a of x plus c over a equals 0. I'm going to substitute the sum and the product of the roots in this equation. So I have x squared minus negative b over a is my sum of the roots, which is 8, multiplied by x, plus c over a is the product of the roots, which is 15, equals 0. Again, I'll replace this 0 by y, and notice that our answers are the same. So you may use any of these two methods. Let's have another example. Determine the equation of a quadratic function whose roots are 3 and 5 and passes through the point 0, negative 3. Remember in my previous lesson where I show you the GeoGebra that there could be many parabolas that will pass through the same roots. So this time we are given a particular point where the parabola passes through, and that is 0, negative 3. We are going to do basically the same process. I'll use the factored form. I'll replace x sub 1 here by r sub 1, which means the first root, x sub 2 by r sub 2, which is the second root. And this y and x's here will come from this point xy. Now let us substitute it. Negative 3 for y. We still have to solve for the value of a, so we'll copy equals a. And then x is equal to 0 minus r sub 1 minus the first root, so minus 3. X again is equal to 0 minus r sub 2, so minus the second root, minus 5. 0 minus 3 is negative 3. 0 minus 5 is negative 5. Negative 3 times negative 5 will give us positive 15. So this will be 15a. To solve for a, I'm going to divide both sides by 15. This 15 will cancel out. Negative 3 over 15 in lowest term is negative 1 over 5. And this is my a. Now that I already have the value of a, I'm going to substitute it again in my factored form. So y is equal to negative 1 over 5. And then x minus r sub 1 is x minus 3. And x minus r sub 2 is x minus 5. We already solved for this in our previous example. Now I'll distribute negative 1 over 5. This will be negative 1 over 5 of x squared. Negative times negative is positive, so it will be 8 over 5 of x. Negative times positive is negative, and 15 divided by 5 is 3. So this will be minus 3. This is now the equation of the quadratic function whose roots are 3 and 5 and passes through the point 0, negative 3. Another example, my x values now are negative 4 and 1/3. Moving this on this side, this will become x plus 4 is equal to 0. I'll eliminate first this denominator, so I'm going to multiply both sides by 3. So this 3 will cancel out. I have 3x is equal to 1. Equating this to 0, this will become 3x minus 1 is equal to 0. These are now my factors. So I have x times 3x is 3x squared. X times negative 1 is negative x. 4 times 3x is positive 12x. And 4 times negative 1 is negative 4. Negative x plus 12x is positive 11x. This is now the equation of the parabola whose zeros are negative 4 and 1/3. Try this. Form an equation of the quadratic function whose zeros are 5 over 4 and negative 4 over 5. So this time we have two rational roots, one positive and one negative. So we have x is equal to 5 over 4 and x is equal to negative 4 over 5. Like what we did earlier, I'm going to remove first the denominator. So in this case, I'll multiply both sides by 4. This will cancel out. So I have 4x is equal to 5. In here, I'm going to multiply both sides by 5. This 5 will cancel out. I have 5x is equal to negative 4. Moving the constant on the other side, this will become 4x minus 5 is equal to 0. And this will be 5x plus 4 is equal to 0. Working backwards, these are now my factors. So I have 4x times 5x, that is 20x squared. 4x times 4 is 16x. Negative 5 times 5x is negative 25x. Negative 5 times positive 4 is negative 20. Positive 16x minus 25x will give me negative 9x. Since I'm looking for a function, I'll replace this 0 by y. So y is equal to 20x squared minus 9x minus 20. This is the equation of the quadratic function whose zeros are 5 over 4 and negative 4 over 5. Let us do extra challenge. Create a quadratic function if one root is 3 plus is square root of 2. We are given only one root in this problem, but 3 plus is square root of 2 is an irrational root. And we have learned from our lesson, Nature of the Roots of the Quadratic Equation, that irrational roots always occur in conjugate pairs. Hence, we can determine the other root, and that is 3 minus is square root of 2. 3 minus is square root of 2 is the conjugate pair of 3 plus is square root of 2. Now I'm going to use the sum and product of the roots. For the sum of the roots, that would be 3 plus square root of 2 plus 3 minus square root of 2. Positive square root of 2 and negative square root of 2 will cancel out. So I have 3 plus 3, and that would give me 6. For the product of roots, that would be 3 plus square root of 2 times 3 minus square root of 2. Notice here that our first term is the same as well as our second term. So we have x plus y times x minus y. And we have learned from our lesson, sum and difference of two binomials, the answer will be the square of the first term minus the square of the second term. So x squared, our x is 3, so we have 3 is squared, and that would be 9. Our y is square root of 2, and square root of 2 is squared is 2. 9 minus 2 is equal to 7. Since I already have the sum of the roots, which is negative b over a, and the product of the roots, which is c over a, I will substitute these values in this formula. So we have x squared minus negative b over a, our sum is equal to 6, multiplied by x. We have plus, and c over a is the product of the roots, which is 7, equals 0. To make this quadratic function, I'll replace 0 here with y. So we have y is equal to x squared minus 6x plus 7. For the summary in this lesson, we have learned how to determine the equation of a quadratic function when zeros are given and when zeros and a particular point are given. We also learn how to create a quadratic equation using the sum and product of the given roots. Now it is time to check your understanding. Pause this video for more time. Let us answer. Find an equation of a quadratic function whose roots are negative 4 and positive 2. So we have our roots x equals negative 4 and x is equal to 2. Equating this to 0, this will become x plus 4 equals 0, and this one is x minus 2 equals 0. Working backwards, these are now our factors. So we have x times x is x squared, x times negative 2 is negative 2x, 4 times x is 4x, and 4 times negative 2 is negative 8. Negative 2x plus 4x will give us positive 2x equals 0. Replace 0 with y, so we have y is equal to x squared plus 2x minus 8. This is the equation of the quadratic function whose roots are negative 4 and positive 2. Gets? Our next lesson is solving problems involving quadratic functions.